Hello, my dear friends and the entire student community. Congratulations that you did tremendous hard work of more than 1 year maybe to this most prestigious #1 engineering exam, engineering services exam in India. You know, this means a lot as engineers for us, conducted by UPSC. You recently saw the 12th fail, that is for civil services. But I think every electrical engineer dreams about this job. I hope you wrote well, and we from ESE Engineering Academy and the entire teacher community would like to discuss the solutions, the marks division and the standard of the paper. As usual, ESE Engineering Service Exam Electrical Engineering 2024, it was evenly distributed for all subjects. Paper was moderate, okay, but calculations of some 20% problems are very deep. But you know how to challenge such exams even though there is no calculator allowed. Now here myself, B.S. Krishnavarma, faculty of ESE Engineering Academy since 2009, would like to do the paper analysis, question paper analysis in detail with my friends and colleagues from all the subjects. Yes, today, you know, yes, it is UPSC Engineering Service Exam, okay, for electrical engineering. You know, total 150 questions. We have native marking and 3 hours. We are talking paper 2, that is technical. Prelims we call. Now if you observe the marks division, yes, engineering mathematics 13 questions, electrical materials 9, electric circuits and fields 12 plus 1, electrical electronic measurements 12, computer fundamentals 12, basic electronic engineering plus analog 15, analog electronics 12, signals systems processing 12, control system 12, electrical machines 14, power system 13, power electronics 13. If you see very clearly how evenly it is distributed, and this is happening since last 3 years. Unlike before 2017, as I know as a teacher, it was very unequal distributed. But see the core, the 3 core subjects like you see machines, power system, power electronics are evenly divided. And all this analog circuits, see 12, 12, 15, it is a very evenly divided. Wonderful. So as a student, you know, like you have to balance all the subjects and you should avoid such questions which are like trap, which may include lot of steps, calculation, derivations, etc. But still, yes, this is the marks division. Now I would request my team, great professors in electrical department, to go ahead with each subject discussion. They would introduce themselves, give the subject topic and start. Okay, are you ready? So we will start immediately the discussion of each and every subject with accurate solutions from ESE Engineering Academy.
Good evening to all of you. So I will discuss now total electrical machines questions whatever given today. So around 14 questions we have from electrical machines. Let's see one by one first. So So the lap connected armature winding is suitable for dash. So this is very common question regularly we are getting from lap and wave winding. So lap winding we use for low voltage and high current applications. Low voltage and high current. So it is option. Low voltage and high current. Option A is correct. Next question. Which one of the following statements is not correct regarding interpoles of DC machine? Which is not correct. So they are small yoke fixed poles spaced in between the main poles. So this is correct only. Their polarity in case of generator is same as that of main pole ahead. When there is a generator, ahead should be there here. So this is also correct. So they are connected in parallel with armature so that they carry part of armature current. So this is wrong. Generally we connect interpole winding in series with armature, not with this. And they automatically neutralize not only reactance voltage but cross magnetizing effect also. So this is also right. So only option C is not correct. So they are asking which is not correct here. So option C is correct. A DC series motor. So this is little lengthy one. Here you will get a quadratic equation and you have to solve this and it will take little time. See the procedure here. A DC series motor running a fan at 1000 RPM and takes 50 amps from 250 volt mains. The armature plus field resistance is 0.6 ohm. If an additional resistance of 4.4 ohms is connected in the armature circuit, what is the value of motor speed when the flux proportional to armature current? So this is common, flux proportional to IA in series motor. And here it is not also possible to guess the option which will be the answer directly. So we have to solve because all the options given very nearby. See here, first you have to find back EMF initially. Calculate back EMF first. First EB1 we get, V minus IARA, IA into total resistance. This is 250 minus 50 into total resistance is given as 0.6 ohms. So we get it is 220 volts. Okay. Next we have to calculate EB2, back EMF after inserting a resistance of additionally 4.4 ohms. But here they did not mention what is the armature current. Here given that fan load is there, it is driving a fan now. So in a fan generally load torque is proportional to square of the speed. So in a fan load torque is proportional to square of the speed. And in series motor as usual torque is proportional to square of the current, and equating these two under steady state condition. Now if you equate, IA is proportional to N. So from this we get IA2 equal to, IA1 is there already 50. So IA2 equal to IA1 N2 by N1. So N1 is 1000 and N2 here. So you will get it is 0.05 N2. This is IA2. Okay. Now with this IA2 you have to find EB2. So that is EB2 we get 250 minus IA2 is 0.05 N2 into total resistance. Now how much resistance added additionally? 4.4, already 0.6 is there, that is 5 ohms. Now let us solve this little bit, 0.05 into 5, some equation you will get here. So once you know this, now apply the speed relation. N2 by N1 equals to EB2 by EB1 into phi 1 by phi 2. Now flux proportional to current given. So phi 1 means IA1, that is 50 amps you can substitute, and in place of phi 2 you substitute IA2, that is 0.05 N2. And if you substitute all these values here, you will get a quadratic equation and simplify this. Now from this we are getting the speed approximately 640 RPM. Okay, 640. So from the given option 641. 641. Option B is correct for this. Next question. So this is from induction motor. A 3-phase 60 Hz 25 HP star connected induction motor operates at a shaft speed of 1800 at a no load condition. Actually this 1800 is almost a synchronous speed here, and poles not mentioned, but we have to understand given it is almost synchronous speed, no load condition, nearly synchronous speed it rotates. Let us take it is a synchronous speed directly, and 1650 RPM at full load condition. Okay, little bit speed drops. What are the values of speed of rotor field with respect to rotor? Speed of rotor field with respect to rotor. First one, rotor field with respect to rotor. What is the speed of rotor field always? Synchronous speed. And rotor speed is n. So at full load condition given 1650 rpm it is. So this is ns minus n. ns is 1800 and rotor speed is here with respect to rotor, no, 1650 at full load condition. So we are getting 150 rpm it is. Next, speed of rotor field with respect to stator field. Fields always synchronous speed only, no doubt. So second one, ns minus ns, that is 0 directly. Okay. So 150 rpm and 0. So option C is correct. 150 and 0 rpm. Next question. The rotor input of a three-phase induction motor with a slip of 10% is 100 kilowatt. And what is the value of gross power developed? So this is also regular common question only. Gross power relation required with respect to rotor power. So gross power to the rotor input power. The relation is 1 minus S directly. So P gross 1 minus 0.1, 10%. And rotor input is given 100 kilowatt. So we get 90 kilowatts is the answer. Okay, 90. Option C is correct. Next. What is the percentage voltage regulation of an alternator having 0.75 leading power factor when the no load EMF is given and rated terminal voltage is given? So directly formula it is, substitute in the formula. The percentage regulation is no load to full load divided by full load into 100. So no load voltage is given 2400 and terminal voltage is given 3000 divided by 3000 into 100. So you will get negative minus 20% it is. Okay, minus 20%. Option B. Next. Two identical alternators are running in parallel and carry equal loads. What will happen if the excitation of one alternator is increased without changing steam supply? Two alternators operating in parallel and carrying equal loads initially. Now excitation of one alternator is increased without changing steam supply. Then what happens? It will keep supplying almost the same load. Whenever steam supply is same, definitely it will supply almost same load. And if you see the remaining options, kVR decreases, but kVR actually increase here. And kVA also increase, but the given decrease. Its power factor will increase, but its power factor actually in this case decrease. So only one option, option A is correct. A synchronous motor connected to infinite bus and has constant full load and 100% excitation, unity power factor. When there is a change in excitation only, the armature current will have dash. So here, initially at UPF. Now, when there is a change in excitation only, what happened here? So it will go under leading power factor with under excitation. Synchronous motor always over excitation is leading power factor. So let's check further. And under excitation, lagging power factor. So given leading power factor under, this is wrong. Lagging power factor with over excitation, this is wrong. Leading power factor with over excitation, this is right. And no change. So no change is wrong. So option C is correct for this. Next. What are the values of maximum step rate for permanent magnet and variable reluctance stepper motor respectively? So for permanent magnets, it is very less when compared to variable reluctance stepper motor. So actually it is for permanent magnet, we will get 300 maximum and 1200 for variable reluctance stepper motor. Okay, so next. Consider the following statements regarding ideal transformer. That is, the winding resistance of primary and secondary are 0. This is right. The eddy current loss of transformer is 0. Means actually it is true. The core of transformer having finite permeability. Ideal case, no, infinite permeability should be there. But question is which of the above is not correct? So which of the above is not correct? Which is not correct? 3 is not correct. Only 3. Option C is correct. In a 50 Hertz, 220 by 400 volt, 50 kVA single phase transformer operates on 220 volts 40 hertz with the secondary winding. Supply is now given to secondary side. Okay, so secondary side actually it is designed for 450. Initially 400 and 50 hertz it is operating, but now the given supply is 220, almost 50% reduced. Actually 400, now almost 200, 220 it is, and frequency little bit reduced. Okay, so what about the core losses of transformer? So what happens to hysteresis and eddy current? So if you see here, V by F ratio not constant with respect to secondary. Voltage so much reduces, definitely hysteresis proportional to voltage power 1.6. So voltage reducing, hysteresis loss also reduce, and eddy current proportional to anyhow voltage square in this case. So both will reduce here. Hysteresis and eddy current loss of transformer decreases. Okay, next. 1100 by 415 volt delta star transformer feeds power to a 30 kilowatt 415 volt 3-phase induction motor having efficiency of 90%. So it is a delta star transformer supplying to induction motor. Its efficiency given and its power given, output power it is 30 kilowatt, and its power factor also given 0.833. What are the ratings of transformer and line current of low voltage side? So this one also will take some time, but approximately two options you can eliminate first. How? Here motor output is there and efficiency is there. So you can find motor input power approximately you will get 33 kilowatt something it is input power, motor input, and motor input is nothing but transformer output power, and motor power factor also given, operating power factor. Now if you calculate kVA rating approximately, the input power divided by power factor if you apply approximately, you will get nearly 40 kVA it is. So 40 is there in two options. So definitely we should know what is the current rating, which one also correct. So for this simply you do this motor input power equal to output is 30K divided by efficiency given 0.9. So it is coming around 33.33 kilowatts. So this input of motor itself, output of transformer. What is output of transformer? √3, line voltage given 415, current unknown, power factor given 0.833. Now solve this equation, you will get I2 is around 55.6. I2 is 55.6 we are getting. Check it, this calculation. So once you know I2, kVA also you can find, √3 V2 I2, kVA rating also you will get. So option B is correct here. Okay, next question. The kVA rating of an ordinary two-winding transformer increases when connected as an auto transformer. So whenever we convert a two-winding transformer into auto transformer, its kVA rating definitely increases. What is the main reason? Two-winding will have only induction, but auto transformer additionally conduction. That is, energy is transferred by both inductively and conductively. Option C is correct for this. What are the important characteristics that must be satisfied for the materials used to build the core of transformer? Okay. What is the important properties required for core? High permeability, low hysteresis, high eddy current. Not high eddy current. Losses must be low and high permeability should be there. High permeability, low hysteresis and eddy current losses. Option B is correct for this. Okay. So this is from electrical machines, and next faculty will continue.
So this is Prasad Meghavarna. Now I am taking power systems. Right? So in power systems, we are having nearly 13 questions. So most of the questions are from transmission and distribution. Some questions are from generation. Very little bit questions are from protection and the fault analysis. And there are no questions from fault analysis. One question we are having from the VIBUS. Right. Now see here. So this is from stability. A 50 Hz 4-pole turbo generator rated at 30 MVA, 13.2 kilovolts has an inertia constant of H is equivalent to 10 kilowatt second, which is nothing but kilojoules per kVA. Then what is the value of kinetic energy stored in the rotor at synchronous speed? It is one of the easiest question and one of the previous question also. Right? So what is the kinetic energy stored? The kinetic energy stored is nothing but H into S, where H is given 10 and S is given 30. So that it will be 300 megajoules. 300 megajoules is the answer, right? So that option C is the perfect answer here. Right. And the next question here it is. So this question is the basic question from the HVDC transmission. Many times we have discussed about this type of questions. What are the advantages of HVDC system rather than HVAC system? So which of the following is the correct regarding the advantage of DC transmission? So we know DC transmission is having more power transfer per conductor. So more power per conductor, more power per conductor. Right. And next one is less corona loss, and no skin effect, and high voltage operation. And less cost. So among these, which option is more preferable? So that option A, more power per conductor, all are same. Second one is more corona loss. No, option A is wrong. Right? Second one is less corona loss. Okay, here it is no skin effect. It is also okay. And more the charging current and possibility of higher operating voltage. Right? So more the charging current. So charging current will be less in case of DC system compared to that of AC system. And coming to the next one, less corona loss, okay, and then possibility of operating high voltage, and here it is low voltage. So that option B is the perfect answer, students. Clear, right? So for this question, option B is the perfect answer. And the next question here. This is the next question. Which of the following statement is correct regarding the shunt and series capacitor? Very basic question in the transmission and distribution part. We know shunt capacitor improves the power factor, series capacitor improves the stability of the system, right? So shunt capacitor improves the power factor, whereas series capacitor improves the stability of the transmission line. So that directly we can go for option A, right? And the next question. So this is somewhat a new question related to the smart grid. The advantage of smart grid. If you think somewhat differently, you can give the answer, right? So in smart grid, the model load facts devices and control protection platform as compared to conventional grid. So it is more dynamic and adaptive and defined nature. This is option C for the next question. Right? We'll see the next question here. A large hydropower station has a head of. So that they have given the head of 324. H is given 324 meters. And average flow rate is given. Flow rate is given 1370 meter cube per second. And they are asking what is the available hydraulic power. So what is the hydraulic power equation? The hydraulic power is nothing but eta W Q H. So as eta is not given, you can take it as 1. So flow rate is W is 1000 into 9.81. Right? So where Q is given 1370 and H is given 324 divided by 1000 kilowatts. Right? If you calculate that, you will get approximately 4354 megawatts. So that nearest answer is option B, 4350 megawatts. Option B is the perfect answer for this question. Right, students? Now we'll see the next question here. Which of the following statements is correct regarding superheaters in steam power plants? Right? So in case of steam power plants, in modern utility, high pressure boilers more than 40% of the total heat absorbed in the generation of steam takes place in the superheaters, right? So first option is directly the correct one. More than 40% of the steam, so is heat is absorbed in the generation of steam, right? So in the superheaters. And the next question here, what are the advantages of bundle conductors? Very, very basic question. What are the advantages of bundle conductors, students? Right? So the bundle conductors are having less value of reactance or inductance, more value of GMR, and less value of potential gradient, right? So that bundle conductor reduces inductance. As a result, reactance will be reduced and radius will be increased, so that GMR will be increased and potential gradient E will be reduced. E will be reduced, so that corona power loss will be less, right? It is one of the easiest question. Option A is the perfect answer, right, students? And the next question, if the loading on the line is less than that of surge impedance loading, then which of the following statements is correct? So this is one of the good question they have given in this year, right? So whenever loading is less, then loading is less than that of surge impedance loading. So as a result, as load is less, current in the system will be reducing. Therefore, the energy stored because of current in the inductor, half Li square will be reducing. Means electromagnetic energy will be reducing. When electromagnetic energy is reducing, that electromagnetic energy is converted into the electrostatic energy. Means electrostatic energy will be increasing. Therefore, capacitor is more dominant. Capacitor is more dominant. When capacitor is more dominant, power factor, line is of capacitive nature. Line is of capacitive nature. So under this condition, as electrostatic energy is increasing, half CV square will be increasing. As a result, voltage will be increasing. Therefore, we can say the receiving end voltages are more than that of the sending end voltages. As line is of capacitive nature, the line delivers reactive power, so that it is not going to absorb any reactive power, it is going to deliver the reactive power of the system. So the absorbed reactive power is less than that of the generated reactive power, and receiving end voltage is greater than that of the sending end voltage. So that option B is the perfect answer here. Right, students? So now we'll see the next question here. What are the overall diameter and dia of metal sheath? So this question is having some ambiguity here. They are asking both are same, overall diameter and diameter of two metal sheath, both are same only, na? But if you think it is inner diameter, then we can get the answer, right? So suppose if it is inner diameter, then the answer will be, so they have given for most economic operation of the cable, the value of capital R by small r is equivalent to E, and the value of E max is nothing but V by R into ln of capital R by small r. R by R is equivalent to E, therefore ln of E will be 1. So E is given G, that is 60 kilovolts per centimeter, which is equivalent to voltage is 80 kilovolts divided by R, where R is equivalent to 80 divided by 60. It is 8 by 6. It is 4 by 3. 4 by 3. And they are asking the diameter, so that it will be 2 times of R. It will be 2 times of 4 by 3. Right? It will be 2.66 centimeters. Right, students? This is correct when you are thinking this is overall diameter as the inner diameter. Otherwise, question is wrong completely. Why? Because they are given overall diameter and metal sheath diameter, both are same only. Clear, right? Now, when small diameter is 2.66, what is the capital diameter? It is E into small diameter. It is 2.66 into E. But option A may be the correct answer, but this question is having some wrong statements. Right, students? And the next question, which of the following is correct regarding reduction of corona loss? Very common question. So reduction of corona loss. Corona loss can be reduced by, so the electric field intensity is inversely proportional to the radius of the conductor, and it is directly proportional to the corona power loss. So that to reduce the corona power loss, we have to increase the radius of the conductor. Means whenever diameter of conductor is increased, right? Diameter of conductor is increased, corona power loss will be reduced. And more diameter conductors are nothing but hollow conductors and bundle conductors. So that by the use of large diameter conductors or hollow conductors or bundle conductors, the corona power loss will be reduced. So that corona losses can be reduced by using large diameter conductors, hollow conductors and bundle conductors is the perfect answer here. Option A is the perfect answer. Now see the next question here. Which of the following types of relay is used to give directional feature to the reactance relay? We know reactance relay is a non-directional relay and impedance relay is also non-directional relay. Which is directional relay? More relay. So whenever you are giving more relay operation to the directional relay, then only it will become directional. So what is the correct answer? More relay. Right, students? Now we'll see the next question here. Right. So what are the values of breaking current and making current? Right. It's a GENCO level question, right? So many times given in GENCO. Right. So breaking current and making current by giving the breaking capacity. The breaking capacity is given as 2000 root 3 MVA, which is nothing but root 3 times of V line into the breaking current, where the breaking current is nothing but 2000 root 3 into 10 power 6 divided by root 3 into line voltage is given 20 into 10 power 3. So if you calculate this one, you will get 100 kiloamperes. And whereas the making current is 2.55 times that of the breaking current. So which is 2.55 into 100. It is 255 kiloamperes is the answer, right? So that option A is the perfect answer. Right, students? And the next question here, the nodal admittance formation using the nodal voltage as the independent variables is most economic. Why Y bus formation is preferable than that of Y loop formation, right? So whenever you are having a power system network like this, for a power system network, always you are calculating the bus voltages rather than that of the loop currents. Clear? So here we are having two loops, so that loop analysis will become difficult, whereas nodal analysis will be very easy. It is having less number of equations, so that less calculating time and the computer memory required is also less. So that with respect to that one, both are good in view of both computer time and memory. That is the perfect answer, students. Right, students? So these are the questions we are having in the power systems. And the next faculty will take care of the next questions, right?
Yeah, hi dear students. So in Engineering Services 2024, Electrical Engineering, let us check it out. The questions from devices part, okay. Of course, this is the common question paper, Basic Electronics Engineering and Analog Electronic Circuits. So circuits paper, my faculty team will be discussing, whereas in the devices portion, what I discussed in the class, okay, I'll be discussing those type of questions, and most of the questions, they came in the exam, similar to the questions what we have discussed in the class. So if you check it out, the very first question, guys, here, the mobilities of free electrons under holes in a pure silicon. We know that this is the given semiconductor, which is the silicon, and clearly specified electron mobility as well as hole mobility. What is electron mobility, guys? It is given as 1300 centimeter square per volt second. Correct, dear students? Whereas hole mobility, it is around 500 centimeter square per volt second. Right. So what is the intrinsic conductivity? That is sigma I. Sigma I is how much? Very simple question, guys. Intrinsic conductivity we are supposed to find, and of course we are so lucky that examiner has given the intrinsic concentration of carriers at a 300 Kelvin, which is an operating temperature, and it is around 1.5 into 10 power 10 per centimeter cube. In the class I told you, if they did not mention, you need to remember these values. We're so lucky that examiner has specified this value in the given question. So what is the formula, guys? So sigma I is equals to Ni cube into what here? Mu n plus mu p. Correct or not? That's a simple formula, direct formula. So what is Ni? 1.5 into 10 power 10. And it's a charge 1.6 into 10 power minus 19 coulombs into mu n plus mu p. Both are in centimeters, no need of any conversion. 1300 plus 500. That's it. So if you could solve, you'll be getting around 4.32 into 10 power minus 6 mho per centimeter, or we say Siemens per centimeter. So 4.32 into 10 power minus 6 Siemens per centimeter. Option B is apt for the given question. Very simple question you got. Second question. What happens to the depletion region? Okay, depletion region and the depletion region capacitance. Let me say, if I consider WDEP is the width of depletion region, and a CJ, or we say CT or CJ, both are right. Transition capacitance, or a depletion capacitance, or a junction capacitance. Fine. What happens to the depletion region and a depletion region capacitance of a PN junction diode with increase in reverse bias voltage? That means we need a relation between the capacitance with voltage and a depletion width with voltage. Very interesting. Students, what is depletion width formula? Default, we consider always a step graded diode, right, dear students? So under root 2 epsilon by Q into 1 by Na, or 1 by Na plus 1 by Nd, correct or not, into the diode voltage, correct or not? So I can say from this expression, depletion width directly proportional to universally if I take nth root diode voltage. Nth root diode voltage. Whereas what is junction capacitance formula? Epsilon, epsilon A by depletion width. Therefore, junction capacitance inversely proportional to nth root diode voltage we are going to get. Correct or not? So this is relation between diode voltage with the depletion width, diode voltage with the junction capacitance. Now speak out, guys. What happens? Increase. That means if diode voltage is increased, no doubt. Tell me, guys, depletion width will be increased, whereas junction capacitance will be decreased. So you please check it out. The depletion region shrinks, decrease. Absolutely wrong, because the depletion width needs to be increased. So the depletion region shrinks itself, absolutely wrong, because if the voltage increases, depletion width increases. So the depletion region widens. This is right. Depletion region must be increased, and depletion region capacitance must be decreased. Option C is apt, I believe. Check out option C also, guys. So the depletion region widens, whereas the depletion region capacitance increases. Absolutely wrong, because depletion region capacitance must be decreased. So very interesting question they have asked in the exam. Check it out. The third question what you have in the devices part. In an N-type, okay, the given semiconductor is what, dear students? N-type semiconductor. The Fermi level is 0.3 electron volt. Guys, this is EC, and I can say this is EF. EF is the Fermi level for N-type semiconductor. So this Fermi level is 0.3 electron volt below conduction band. So this is 0.3 electron volt examiner has given. 0.3 electron volt below conduction band at a temperature. So at a temperature T equals to 300 Kelvin. Very interesting. Now, if the temperature is increased to 360 degree Kelvin, I mean to say, take it as a T1. Now, at a T2 is equals to 360 degree kelvins. Now let me know what is the new position in the Fermi level. I hope you know that when doping increases at a constant temperature, Fermi level move towards the conduction band in N-type. When temperature increases at a constant doping, Fermi level move away from conduction band, maximum reach to the center of energy gap. Am I right, dears? Therefore, what is the formula we have? Direct formula, as I discussed in the class, EC minus EF2 by EC minus EF1 is simply equals to T2 by T1. So this is the new Fermi level at a temperature T2. This is the Fermi level at a temperature T1. Now please let me know, dear students. Therefore, EC minus EF2, which is a new Fermi level at a temperature T2. So T2 is how much, guys? T2 is a 360 degree Kelvin by 300 into the Fermi level at the 300 Kelvin, which is 0.3 electron volt. So I believe if we could solve, you'll be getting around 0.36 electron volt. So this is the Fermi level what I have at a temperature of 360 kelvins, which is a new Fermi level at a temperature which is below conduction band. Check it out here, dears. Remains unchanged, which is impossible. 0.26 itself is wrong. 0.36, yes, the magnitude is correct. Whereas above conduction band, which is impossible, because above conduction band indicates that must be degenerative semiconductor, okay? Whereas 0.36 electron volt below conduction level, it is absolutely apt for the given question. Right, dear students? So circuit part, my professors, I'm going to say my colleague will be discussed, and the next subject, I think my colleague is ready. So have a great success in your life, dears. Engineering services, just rocking. Thank you.
Hi everyone, now I am going to discuss the questions from electrical and electronic measurements. This includes electrical measurements questions, electronic measurements as well as transducer questions. Here the first question is, this is related to average value. He is asking, right, find the value of average value as well as range of error he is asking. If you are finding all values 10.03, 10.10, 10.11, 10.08, if you are finding the average value, you will be getting average value as 10.08, and then range of error formula directly maximum value out of the given values minus minimum value out of the given values divided by 2. What is the maximum value? 10.11. The minimum value is 10.03. If you are simplifying this, you will be getting 0.04. So therefore, answer here is 10.08 and 0.04. Option B. It's a basic question. And next question is related to potentiometer method of resistance measurement. He has given voltage across the resistance under test, that is 0.4221 volt, And then standard resistance S is given as 0.1 ohm and standard resistance voltage is given as 1.0235 volt. He is asking unknown resistance as well as current respectively. We know the formula VR by R is equal to Vs by S. Right? If you are using this formula, you will be getting the R value as 0.04124 approximately, or 0.0412, and current is equal to VR by R we can take, as well as Vs by S also we can take. If you substitute these values, you will be getting 10.235. So these are the values. So option here is A, 0.0412 as well as 10.235 amperes. And next question here is, this is the question related to PMMC instrument. Moving coil voltmeter or moving coil instrument itself indicates PMMC. This question is a little bit lengthy, but simple question. PD is equal to BIN into A. Right? In this, B value is given and N and A, all values are given. You will be getting TD in terms of I value. And TC is given in this question. What is TC? 240 into 10 power minus 6. 240 into 10 power minus 6 is given. At the final position of the pointer, we know TC is equal to TD. So therefore, this value and this value both must be equated. If you are equating these two, you will be getting the current value as 20 into 10 power minus 4 amperes. Current is given, current is obtained. But what he is asking here, the resistance value must be added in the circuit to get 1 volt per division. This is the key point here, 1 volt per division. How many divisions are there here? He has given that 100 divisions in the question. So therefore, here 100 divisions are given and he is asking 1 volt per division. So therefore, it becomes 100 volt. So therefore, here resistance is equal to 100 volt by current is 20 into 10 power minus 4. So therefore, if you are simplifying this, you will be getting 50 kilo ohm. So answer here is straight away option C. Right? Next question. Which one of the following statements regarding correct regarding moving iron? This is straight away question. Moving iron instrument scale. What is the scale nature? If you remember the scale nature of this moving iron, answer is straight away. Always moving iron instrument indicates higher value of the measurement for the descending values. Why is the scale itself is theta proportional to I square. This scale is called as square law scale. Otherwise, what we can say, crowded at the beginning, right, and spread out towards full scale value. This is the technical name of square law scale, which is there for MI. So based on this, we can straight away say that it indicates higher value of the measurement for descending values. Next question is, it is extension of range method, moving coil instrument, right? The full scale value IM is given as 10 milliampere. When the potential difference, nothing but VM is given, this is 100 millivolt. What value of shunt resistance to have 100 amperes range, extension of range? What is the formula? RESH is equal to REM by I by IM minus 1. It's a basic formula. But in this, IM is given and then VM is given, I is also given. What is I value? 100 amperes. But only one problem is RM is not given directly. But if you are using these two, we will be getting RM value. RM is VM by IM. If you substitute that value here, now all values are available. If you are simplifying this, you will be getting the value as 0.001 ohm, nothing but 1 milli ohm. Only basic formula, but RM is given indirectly. Right. Next question is, the power, this is a 2 wattmeter method. This is the very, very general question, very popular question. Here, he is asking 1 wattmeter reading is positive other wattmeter reading is negative, but he has given that both are not equal. Both are not equal. And in this 2 wattmeter method, we have only 5 conditions. This is a question related to one of those conditions. Right? What is that condition? 2 wattmeter readings are not equal and opposite. Nothing but not equal and opposite. One is positive, one is negative. Then the range of power factor is, 0 to 0.5. Nothing but according to the options we can select, this is less than 0.5 because neither 0 nor 0.5 in between. So suitable option is less than 0.5. And next question is, this is the question from electronic measurements, that is a 3.5 digit DVM question, right? Here in this 2 errors we have to find out, 0.5% of the reading as well as plus or minus 1 digit or plus or minus 1 count we say. So what is the full scale value? 10 volt range. What is the red value? 5 volt. So therefore, error 1 I am finding. What is the error 1? 0.5% of reading, that is 5 volt. You will be getting 0.5 by 100 into 5. You will be getting 0.025. You will be getting 0.025 volt. This is one error. After that, he is asking plus or minus 1 digit, but generally we say plus or minus 1 count we say. Generally they will be using the word as count or digit. In order to get 1 count, we need to find out the resolution. What is the resolution formula? 1 by 10 power n. N is the full digits, that is 3 into. What is the scale range? 10. So therefore, 10 volt by, what is it? 1000. You will be getting 0.01 volt. And this is 1 digit error. So therefore, error is equal to 1 digit or 1 count we can say. 1 digit or 1 count, that is 0.01 volt. Sir, this is one error and this is one error. If you are adding these two, you will be getting 0.035 volt. Right? Next question. It is also straight away standard values. What are the values regarding potentiometric recorders? These are the standard values. Here, sensitivity of 4 volt per mm and error is less than 0.25%, bandwidth is 0.8 Hz. These are straight away standard values related question for option A. Next one, it is electronic measurements again. Rise time is equal to 0.35 by bandwidth. 0.35. What is the bandwidth he has given? 10 megahertz, 10 into 10 power 6. And this is the question related to transducer, straight away basic question. In order to select the transducer, right, which of the corresponding characteristics must be considered? Sir, first option input characteristic, second option output characteristics, third one transfer. But actually, while selecting a transducer, we need to consider all the characteristics. That's why input, output as well as transfer. So all characteristics must be taken into consideration. And one more question from the transducer is the last question. If a transducer has output impedance, that is Z0, what is Z0? 1 ohm. And load resistance, we can say ZL or RL, no problem, 1 kilo ohm. So according to the given data, Z0 is less than ZL. If Z0 is less than ZL, it acts as constant voltage source. Suppose Z0 is greater than ZL, it acts as constant current source. So according to the given data, answer here is constant voltage source. So these are the questions from the measurement subject. Next subject will be continued by the faculty.
see here total 12 questions from signals and system subject. Let us see the first question. What is the relationship between h of 1 and h of 2 from the endpoint DFT of h of n equals to e power minus n by 5 and given that capital N is 3. Here you have to identify the important thing is once you see the nature of h of n, e power minus n by 5 means it's purely real. H of n is real means what is the relation? We know that capital H of k is equals to h star of n minus k. This is valid only if h of n is real. So what is the capital N value given in the problem? Capital N equals to 3. So h of k equals to h star of 3 minus k. If I substitute k equals to 1, then capital H of 1 equals to h star of 2. So once you see the option, which one is correct? B is the correct option. H of 1 is equals to h star of 2. Okay, it's simple question from DFT chapter. Next, what is the autocorrelation of the energy signal x of t is equals to e power minus t u of t. E power minus t u of t. Yes. What is the autocorrelation function? Rxx of tau is equals to x of t convolution folded version of x of t, that is x of minus t, that is e power minus t ut convolved with e power t u of minus t. If I apply Fourier transform to this autocorrelation function, then right side becomes multiplication 1 by 1 plus j omega into 1 by 1 minus j omega. This becomes 1 by 1 plus omega square. If I take the inverse Fourier transform on both sides, it's become 1 by 2 e power minus mod tau. So the right option is D is the right option for this question. Next question. The response of an LTA system to u of t is g of t equals to this much given. What is the response when x of t equals to 1? First consider the first information. What is the first information given? Input is how much? U of t. So what is the Laplace transform of this input? 1 by s. Second, what is the output for this u of t? G of t is equals to 2 e power minus t ut minus 2 e power minus 5t ut. First try to find the transfer function. For this, if I apply Laplace transform, 2 by 2 e power minus t, okay, here 2 is not there here. Okay, here 2 is not there. Okay, only minus e power minus 5t. So 2 by s plus 1 minus 1 by s plus 5. What is the transfer function? H of s is equals to g of s divided by x of s. So what is the h of s value here? If I divided by h of s, 2s by s plus 1 minus s by s plus 5. This is the transfer function of the system. Second time, see what is the input given? X of t equals to 1 given. X of t is equals to 1 means I can write this as e power 0t. If input is e power s naught t, what is the output? E power s naught t into h of s naught, that is e power 0 to 0t into h of 0. What is capital H of 0? If I substitute in place of s0, 2 into 0, 0, this is 0 by anything 0. So h of 0 becomes 0, 0 into anything 0. So what is the output for this question? Y of t is equals to 0. So the right option is A. Next question. What is the value of x of t for t greater than 0 from the given Laplace transform? You can solve it by option elimination of option method. How many terms are given here in the denominator? 3. So is there any pole 0 cancellation is possible? No. So compulsory in the inverse Laplace transform you will get 3 terms. So there may be chance that C and D. Once you see the poles, s plus 1 means compulsory will get e power minus t term. So you see the C option here, e power t is there, here e power minus t is there. So you can easily choose the right option is D is the right option. Okay? Yes. Next. If the input signal is x of n equals to sine omega cn by pi, then what is the energy of the signal? You can solve this question by using Rayleigh's energy theorem. So what is the Rayleigh's energy theorem is energy of x of n equals to 1 by 2 pi integration minus pi to pi mod x of e power j omega whole square d omega. Okay.
So what is the signal x of n given? First to find the dt of t. Sinc omega cn by pi. So we know that sinc x is equals to sin pi x by pi x. So sin omega cn by omega cn. I can write this as pi by omega c into sin omega cn by pi n. Now it is in the standard form, sin a n by pi n. What is the dt of t of this? Rectangular of omega by 2a, that is minus omega c2 plus omega c. And what is the amplitude? Pi by omega c. So if I substitute in this formula 1 by 2 pi integration minus pi to pi, what is x of e power j omega value? Pi by omega c. So whole square, pi square by omega c square d omega. So if we simplify this, the right option is E answer you will get, okay, pi by omega c. Okay, just you simplify that integration, you will get the right option as pi by omega c. And the remaining questions will be discussed by Narsimham sir.
Thank you, Srikanth. Let us extend the questions. The last question asked is on Parseval's theorem or Rayleigh's energy theorem. To extend that, one more property is added in this particular question. X of n is given as some set of data. We are expecting an area under spectrum whole square, where we are in need of using two properties. That is frequency differentiation extra. N into xn will have spectrum as j into d by d omega x e power j omega. What is expected here? Integral minus pi to pi spectrum whole square, that is differentiated spectrum. So it is nothing but 2 pi into sigma minus j n xn whole square with modulus. Just our job is taking magnitude and multiply by every sample amplitude multiplied by respective time index. That arrow mark indicates sample at origin, you are aware. This is sample at 0, just you have to find out sample by sample product. After doing all that enjoyment, that will create 316 pi. This is a straightforward question from our material, volume 1. Straightforward question. Okay, let us see the next one. Previously only Parseval's theorem, here extra frequency differentiation. Yeah, this is actually Hilbert transform. Generally they use it to have minus sign here, plus sign here. It is opposite enjoyment here. When you draw the spectrum roughly 0 to pi range, it is mentioned to be 2j minus pi to 0 minus 2j. The standard Hilbert transform formula is 2 by pi n sine square n pi by 2. Power action fellow, he has given extra 2. That will create 4 by pi n. But generally for a positive range we will have minus j, negative range plus j. So minus sign is missing. So the best possible option you can feel like option D. Otherwise you have to enjoy in exam hall, that to ESE, you cannot waste your time. Integration 1 over 2 pi minus pi to 0, that 2j e power j omega n plus 0 to pi plus 2j e power j omega n d omega. Time waste. 2 by pi n sine square n pi by 2 is the standard one. Just reverse it. Extra negative sign is missing. So the best possible option is option D. Minus sign is missing. This is another funny question. Del of n minus n naught dt of t is e power minus j omega n naught. Based on that, what is the Fourier transform of this one? E power minus j omega into 1. Next one, e power minus j omega into adjustment of 2. That will make 2 cos. Simple. Okay. Options are blunder mistake. Cos omega naught and un is given. If un is not given, then you can choose blindly the first option. Because of this extra un, if you want to proceed, if you want to waste your time, generally it is not possible in the exam hall. It is a different story. The Fourier transform of Un is standard 1 by 1 minus e power minus j omega plus pi into del omega. Then we are using some modulation property. Even if you have done by that method, no option is correct. If Un is not there, then you can feel first option is correct. Normal cos omega naught n standard Fourier transform. Okay. Initial value, final value, bacha, very simple one. What is y0 formula? Limit s tends to infinity, s into y of s. When you cancel with this, that extra s cancellation, then it becomes limit s tends to infinity, 10 into 2s plus 3 by s square plus 2s plus 5. After substitution, you will get 0. Our luck is, which option has 0? Option D, no need to solve final value also. Even if you solve, 6 is the answer. What is final value theorem? Limit s tends to 0, s into ys, you apply 30 by 5, that will make 6 as the answer. Okay. Sync pulse, that fellow want the area under that function. Spectrum at 0, according to Fourier transform definition, spectrum at 0 corresponds to area under the signal, we are aware. Don't bother about that shift, that makes no difference for us. Normally, sin 80 by pi t means we are sketching the spectrum as rectangle from minus a to a. I am not bothering about that shift value here. That will make no difference for us. 10 sinc of t by 7, after making the required adjustments, it becomes 10 sin pi t by 7 by pi t by, take its spectrum. So it will have a rectangular spectrum for certain range with amplitude as 70. That extra shift that makes no difference for us because we want spectrum at origin. What is spectrum at origin? 70. Straightforward question. Area under the signal corresponds to taking spectrum at. We have that shift that makes no difference for us. Normal time shifting. That will create extra e power minus j omega t naught. Anyway, we want the value at origin. Correct or not? Let us see the last model of signals. Del of alpha t, we are aware 1 by mod alpha del t. U of 3t, scaled version of step function for positive time is same as ut. So I can write the first term del of 3t as simply 1 by 3. U of 3t as simply ut, take its Laplace. So 1 by 3 Laplace, of course, what I missed here? Del t. 1 by 3 del t. 1 by 3 Laplace is 1 by 3, ut means 1 by s, that is s plus 3 by, simple pole at origin, automatically ROC sigma greater than 0, real part of s. That will lead to option D. Very simple models you got this year. That's all. I am handing to next faculty member.
ask the 13 questions. All are simple questions. First one, it is a differential equation. You ask the transfer function. Simply apply Laplace transform. Once you apply Laplace transform here, you will get it what? C of S, if you take it common, S cube plus 4s square plus 6s plus 3 equal to R of S, if you take it common. So you will get S square plus 6s plus 4. Then C of S by R of S is the right transfer function. We will write S square plus 6s plus 4 divided by S cube plus 4s square plus 6s plus 3. So option A. Next. So here you are asking the steady state errors for the what? Step, ramp and parabolic inputs are given. Here if you observe the G of S given 120 into S plus 2 divided by S plus 3 into S plus 4 given. So it is a type 0 system. Type 0 gives the constant steady state error per step input. So what is the steady state error per step input? A by 1 plus Kp. So A is given 3 U of t, 3 divided by 1 plus Kp. Kp is simply numerator constant by denominator constant. So that means 120 into 2 divided by denominator 3 into 4. Then if you solve it, you will get 3 by 21. So 3 by 21 option is there in A. A is correct. The next one also belongs to steady state error. So here type 1 system. So G of S given. So 100 into S plus 2 into S plus 6 divided by S into S plus 3 into S plus 4 given. It is a type 1 system. Type 1, first input is what? Step input. Type is greater than input, you can consider. Then the first one, for step input, you will get the error is 0 per step. For ramp, you will get constant. For ramp input, ESS equal to A by KV. So A is nothing but 4. For T, so A is 4. KV is called what? Numerator constant means 100 into 2 into 6 divided by 3 into 4. You solve it, you will get 1 by 25. So 1 by 25 is there in option B. Option B is correct. Next here, we need to use the RH criteria. The characteristic equation is S power 5 plus 2S power 4 plus 4S cube plus 6S square plus 2S plus 5. If you write a Routh tabular form, S power 5, S power 4, S cube, S square, S power 1, S power 0, 1, 4, 1, 4, 2, next 2, alternate 6, next 5. Solve this, you will get the year 1 minus 0.5 you will get, year 7, 5, year minus 1.21 you will get. So here you will get 5 unstable, sign change is there, system unstable. That means answer A is correct. Next year, actually here K plus 1 should be there here. Then K plus 1 is there, option X. Strictly speak here no option matches. But one way we can consider option A. If you consider here 2K plus 1 greater than 0. Next, which one of the following is correct option? Simply it is a what? Minus 90 degrees. That means simply pole at origin. So 1 by S. Next year, root locus technique can be used to do the transient analysis and stability. So that means option A is correct.
So next, so here actually they should mention the gamma value, nothing is mentioned. So that's why it is very difficult to decide. So we can, it is, if you mention the gamma greater or lesser and that differentiation should be there, that is not mentioned. So next, which one of the following statements are a state variable? State variable is a feedback. It considers initial conditions and states, and model of the system is not unique. This is option B is correct. State model is not unique. So option B is correct. Next here, this is a Jordan canonical form, JCB. If we divide into Jordan block here, -1 equivalent B matrix is not 0 and -2 equivalent also not 0. That means the system is what? Controllable. Option A is correct. Next is, it is a simple definition of observability. If you are able to identify the initial states of the system by observing the output in a finite time interval, then we can call it is a what? Observability. Next here, we need to find the output C of S by R of S, that is called transfer function given 20 divided by 0.21 S plus 1 is given. R of S 8 by 0.8 by S is given. So that means 20 into 0.8 divided by S into, so 0.21 S plus 1. So here it is unity feedback given. So first you have to find closed loop transfer function. 1 minute. First we require to find here closed loop transfer function. So because unity feedback mentioned, so closed loop transfer function C of S by R of S equal to 20 divided by, so 0.21 S plus 1 plus 20. That means you are getting 20 divided by 0.21 S plus 21. Then R of S 8 by S, 0.8 by S. So that means what I will get? 20 into 0.8 divided by S into 0.21 S plus 21. So if you find here partial fraction, C of S you will get 0.76 by S minus, 1 minute, minus 0.76 divided by S plus 100 you will get. Then you apply inverse Laplace transform, you will get 0.76 into 1 minus e power minus 100t, means here t by 0.01 we can write. So option B is correct. So next my colleague will continue.
Hi friends, good evening. So let us see the questions given in communication systems in electrical branch. Simple, straightforward questions. 5 or 6 questions are given. Compared to last year, actually the number of questions have reduced and direct questions are given. So let us see the questions one by one. Okay. An AM commercial broadcast receiver. So here he is talking about a commercial broadcast receiver. He is considering an AM system. In a frequency band, means the operating frequency range is from 535 kilohertz to 1605 kilohertz.
with an input filter factor of 54. So filter factor is nothing like attenuation means how much part of your frequency will be considered. That is what is called as a filter factor. What are the bandwidths of the low and high ends of your RF spectrum? So if you take this 535 and divide with 54, approximately it will be 9 point something. So very closely, if you take, it will be around 10. And 1605 kilohertz, if you divide with 54, you will get around 29.63. So best possible choice for that will be your option C. Okay, so that is how you can get that value pretty easily, right? Next, consider the following statements relating with a digital communication system. So what are the statements he has given? Digital signals can be coded to yield extremely low error rates and low fidelity, correct. Digital signals can be coded to yield extremely low error rates. It is not bit rate, error rate. So number of errors we can reduce by doing a digital communication, and low fidelity, correct only. Digital signals are easier to encrypt for security and privacy, that is also correct. Digital signal storage is expensive. No, storage is actually very cheap. Analog storage is very costly because you need to store it on magnetic tape or like a CD drive like this. But digital signals nowadays you are storing on directly pen drives, which are very, very cheap, and you are getting a very high memory space also. So you can remove that option 3. I think option 1 and 2 are perfectly correct. So you can go with option A. Okay. Next, general question that is nothing related actually with complete communication. Even with common sense also you can tell. Next, consider the following statements related with the time division multiplexing technique. One of the multiplexing technique used in digital communications. TDM is readily implemented with high density VLSI circuit, yes, because we are dealing this with the digital communication part, correct only. TDM synchronization is less demanding than that of suppressed carrier FDM, no. Whenever you go with the TDM, synchronization is must, because you use a commutator and decommutator, a transmitter and receiver, both should operate with the same speed, otherwise errors will automatically come in your system. So synchronization is very important. When compared with FDM, it is more important in TDM, but he is telling that it is less demanding. It is actually high demanding. TDM crosstalk immunity does not depend on transmission bandwidth, correct only, because TDM is essentially dividing in time slots with different bands. So it does not depend on the total transmission bandwidth. So obviously you can remove 2, 1 and 3 you can go. So option D will be the correct choice. Okay. Next, let us go with the next question. What is the net baseband bandwidth in frequency division multiplexing? So what is he asking? He is asking what is the total bandwidth in FDM system. So what is this FDM system? Your x-axis is frequency. You are dividing the spectrums in different frequency bands. So I may have a spectrum like this, I may have a spectrum like this, I may have a spectrum like this. So what is the total bandwidth? It is a sum of individual bandwidths, means this value and this value. So let us assume this is like some B1, B2 and B3. So total bandwidth of the multiplexed signal will be B1 plus B2 plus B3. Along with that you are giving guard band, empty space that you are leaving between 2 successive stations. We call it as guard band. So for 3 signals you are obviously using 2 guard bands. So this will be the total bandwidth. Now you can see your options, only one that is satisfying here is, it is a sum of modulated message bandwidths, means individual ones, and guard bands. So only possible choice is option A. You can go with this. Remaining does not satisfy with the, it is not the product, it is sum, and value obtained by subtracting, no subtraction will come and no product will come. So only sum will come. So that is how you can easily identify your option. Next, during the serial transmission means 1 by 1. A group of 512 sequential 12-bit data words is transmitted in 0.016 seconds. What is the speed of transmission? Speed of transmission means what? He is essentially asking what is the bit rate of your system. So obviously you are having a 512 sequential data. Each data is taking 12 bits and you divide it with this 0.016, because you have to multiply it with sampling rate, but sampling time is indirectly given. So if you simplify that, I think you will get around 384 into 10 cube or 384 kilobits per second. This is just like finding a bit rate of the total system. So this will be your correct choice. Okay. Next. So these are all the questions given from communication point of view. So my next colleague will take the remaining part of the paper. Thank you.
Okay, so let's look at questions from analog circuits. It seems EDC part is already covered, so I'll look at analog. So in a Wien bridge oscillator, if the value of R is 10K and the frequency of oscillation is 10K, what is the value of capacitor C? So this is a very standard question. The frequency of oscillation is simply given as 1 by 2 pi RC. 1 by 2 pi RC. So you can just substitute to get the solution. So you have 10K here, 1 by 2 pi, R is given 10K, and C. So from here you can calculate the value of C. From here you can calculate the value of C. So it's a simple question. So these are some of the EDC questions. Yeah. So consider the following statements regarding the voltage divider bias. The voltage divider bias configuration uses two DC supplies to provide forward bias. See, the very word self bias or voltage divider bias means single supply. So the first option is wrong. The voltage divider bias provides a very small base current to the transistor compared to the bias current. So definitely we don't want the voltage divider to load the circuit. So we want to keep the base current as small as possible. And two resistors R1 and R2 form a voltage divider that provides base bias to the transistor. So the very name voltage divider means R1 and R2 at the input side. So option 2 and option 3 are correct. B is the correct option. So consider the following statements regarding common base transistor amplifier. In an active region, see whether it is common base or common emitter, the moment they say an active region, the base emitter junction should be forward and collector base junction should be reverse. So just to confuse the student, he has given common base transistor amplifier. irrespective of any configuration, in an active region, the collector base junction is forward. That is wrong. Base emitter junction should be forward, collector base junction should be reverse. In the cutoff region, the collector base and base emitter junctions are both reverse bias. It is correct. So if it is a cutoff region, definitely both are reverse bias. In saturation region, the collector base and the base emitter junctions are both forward bias. So 2 and 3 are the correct answer. Cutoff region, both junctions are reverse. In saturation, both junctions are forward. So what are the biasing states of collector base junction and base emitter junction in the active region of a common emitter transistor amplifier? So if you want an active region, as I told you, base emitter junction should be forward bias and collector base junction should be reverse bias. So you can see option D, the collector base junction is reverse bias, base emitter junction is forward bias. So this is correct. Now again on the regions of operation, cutoff region means all the current should be 0. So that means P2. And saturation region. In saturation region, the beta value is going to increase. So it is going to be Q3. And in forward active region, beta formulas will obey. IC equal to beta IB is valid only in the active region. So it is R1. So P2, Q3 and R1. So P2, Q3 and R1, B, option B. So consider the following statements regarding negative feedback in an amplifier. It has reduction in the overall voltage gain. So in negative feedback, the overall gain is going to be A by 1 plus A beta. So definitely there is a reduction in the overall gain. It has enhanced frequency response. So that's the trade-off. Whenever the gain reduces, the bandwidth will improve. So definitely it has enhanced the frequency response. It has high output impedance. So high output impedance only when the output side is a series feedback. So it can also have low output impedance also if it is shunt. So 1 and 2 are correct. It has reduction in the overall gain and enhanced frequency response irrespective of any feedback amplifier. Option 1 and option 2 are correct. In a Hartley oscillator, L is given, C is given, frequency is given, L1. So again, this is a standard question. F is equal to 1 by 2 pi root L1 plus L2 into C. So you can see F is given, L2 is given, C is given, frequency is given. So from here, you can get L1 from this problem. It's a just substitution question. So what are the key properties of an op-amp which plays an important role in designing op-amp operated active filters? So when you're designing active filters in op-amp, what are the key properties of an op-amp? So high output resistance. Generally, whenever we design filter, we want to provide isolation. So we want input impedance to be high and output impedance to be low. So let's see, high input impedance, low output impedance, and the possibility of signal amplification to the desired level. So option B is the correct solution. Otherwise, other options you can see, high output impedance, low input impedance. So we don't want the circuit to load at the input side, and the possibility of having signal amplification to the higher. I think option B is correct because we want high input impedance, low output impedance, and the possibility of having signal amplification to the desired level. Okay. Next, my friend is going to continue.
Yeah, now let's look at the solutions for the digital and computer fundamental questions. The first one is this, 121. Sorry for the interruption. Now let's look at the solutions for the digital questions first. First one, a R2R ladder DTA converter is given. He is asking what is the resolution in the given options. We know very well the percentage resolution formula is 1 by 2 power n minus 1 into 100. So here it is a 4-bit DTA converter. Hence it is 1 by 2 power 4 minus 1 into 100. That is 100 by 15. So it comes to 6.67 something. So for this, the correct answer is B. So it is a direct formula based question. Next one. It is the question based on successive approximation A to D converter. You know that in successive approximation ADC, conversion time will not depend on the magnitude of input. So let's see one by one. The output data can be taken out in serial as well as parallel. It's wrong. Why? Because we can take it only in serial fashion, not in parallel. Next, the circuit is less complex compared to ramp ADC. Wrong. Because successive approximation ADC involve lot of changing of bits to ones to zeros and 0 to ones. It requires lot of hardware. Hence, compared to the second one, successive approximation ADC is more complex. As the conversion time not dependent on the analog input, it is a comparatively faster. This is the correct one. So the correct option to this is 3. So in that manner, read the question carefully and try to answer to that accordingly. Next one. How many number of select input lines are there for 1 to 8 T multiplexer? It's nothing but 2 power 3 equal to 8. That is 3 n equal to 3. Okay, so the answer is 3 here. That is a simple and straightforward question. Next one. How many comparators and resistors are used in a 8-bit flash type A to D converter? We know very well in any flash type A to D converter, the number of resistors are equal to 2 power n and number of comparators are 2 power n minus 1. Hence, looking at for n-bit flash ADC, the number of comparators are 2 power n minus 1 and the number of resistors are 2 power n. So this is the correct option for this. Again, the formula based question, you have to just remember what is the type of A to D converter, what is the relation between number of resistors and number of comparators. Now let us look at the solutions to the problems on computer fundamentals. The first one is, it's regarding SDRAM, okay? And he has given so much amount of information about that. And what is the data transfer rate for DDR3? You should understand one thing. DDR stands for double data rate. That means for one clock, the data will be sent twice. Okay, that's the reason we have to do it like this. Given the frequency is equal to 100 megahertz. So that means the time is equal to 1 by f equal to 0.01 microseconds. So this is the meaning of this. One time period is 0.01 microseconds. Like this. So in this duration, it is able to send 64 bits of data. I told it is 2 times that. So in this duration of 0.01 microseconds, it is sending 16 bytes of data. So now what is asking here? So in that case, what is the approximate transfer rate? Means in 1 second, how much he is going to send? So we have to do it like this. In 0.01 microseconds, he is sending 16 bytes. Then in 1 second, how much? So this is going to be, answer is 16 by 0.01 microseconds. That is into 10 power minus 6. So this comes 1600 megabytes per second. So the correct option to this question is this. Okay, that's how you have to calculate for this particular problem. Next one. So here, lot of information is given for the disk drive, but the most important one here is 6000 RPM. Means it is making 6000 revolutions per minute. We have to find for one rotation how much time it's going to take. Okay, so I just do it quickly. So 6000 RPM is equal to 6000, then RPS is equal to, that is revolutions per second, is 60 equal to 100. That means time for one revolution is equal to 1 by 100. That is equal to 10 milliseconds. Okay, this is the information. Then what did he ask you here? Yeah, so it is 10 milliseconds. What is the approximate rotational delay? It's a well-known fact that approximate rotation delay is equal to the time taken for one revolution divided by 2. That is equal to 10 milliseconds divided by 2. That is 5 milliseconds, which is equal to 0.005 seconds. So the correct answer to this question is A. Okay, that's how you have to handle these problems. Right. Coming to this, how many pages are there in the disk if the capacity of virtual disk is given and the space size is given? I think it's very simple. Total memory size has been given. What is the size of each page is given? How many pages are there? Simple. Total capacity divided by each page size. So the answer is 2 MB. Divided by size of the page, 2 kilobytes. So the correct answer to this question is nothing but this. In this manner, we have to calculate the number of pages in a given disk system. Yeah, so what is this one here? So in this one, it is more theoretical question. You can see, I think you can see how to improve computing services. For that, you have to go for the logging. We have to adapt the procedure called as logging. Yeah, next one. In communication process, resides in a temporary queue, and it is regarding the queue question here. What is asking finally? In what way can such queues be implemented? I think you know that it is mostly zero capacity. Okay, zero capacity queues are going to improve the performance. Next one. So this is the process. We'll look into the detailed solution later on about this. Yeah, so coming to this question here, it is a CISC processor, complex instruction set computer. Then what is asking? Which of the above characteristics are not correct? So you have to be careful here. He told that it is having a small number of instructions, that is incorrect. It is having less addressing modes, incorrect. Most instructions can manipulate operands in the memory, this is correct. Control unit is microprogrammed. We know that in CISC computers, the control unit is microprogrammed. In RISC computers, the control unit is hardwired control unit. So what is asking? Which of them is not correct? 1 and 2 only. So the correct answer is this for this. Right, so let's look at the next one. In which of the following process the designer can add easily new instructions? I think it's a very well-known fact. Hardwired control unit, it's not flexible. Microprogrammed control unit, it is flexible. That is the concept we learn. So here he is asking CISC or RISC processor. We know that CISC processor will adapt microprogrammed control unit. RISC program processor will adapt the hardwired control unit. That's the reason CISC is more flexible compared to the RISC. And the correct answer is A. It is a conceptual question here. Yeah, I think this is very straightforward. I want to improve the performance of any CPU. There is no other way. We have to go for pipelining. So pipelining is a well-known process adapted in all the processors so that the performance is going to increase. Yeah. So this one is, it is regarding the root hub. I think if you just read out the statements here, which of the above functions are correct? It performs power distribution, that's correct one. It enables and disables the ports, correct one. It reports status of each port to the user, it's a correct one. So the correct option to this is D. Thank you.
students with lot of patience. I know it's huge time in the night today, but I hope you wrote well, and I'm giving the solutions for electric circuits. Okay. Now, this is the first question. Two perfectly coupled coils. Now, what is the meaning of perfectly coupled coils? That means coefficient of coupling is 1, K is equal to 1. Okay. Yes, perfectly coupled, tightly coupled. Okay, that means K equal to 1. And each self-inductance is 1 Henry. That means L1 equal to L2 is 1 Henry. Are connected in parallel to aid each other, parallel aiding. So, K is 1, self-inductance is equal parallel aiding. First of all, in parallel aiding, total inductance is what? Total inductance is L1 L2 minus M square by L1 plus L2 minus 2M. Aiding na, aiding means more answer means less denominator. But here K is 1 because they are tightly coupled. Then what is the value of M? We know M is K root L1 L2, but K is 1 and root L1 L2 is also 1 into 1. So M is also 1. M is also 1. But interestingly, if you substitute, now this L total become, okay, L1 L2 are however 1 minus M square is also 1 by L1 plus L2, 1 plus 1 minus 2. So answer is 0. It is simply 0. Answer is 0. Okay. So ideally, it is very interesting that is it physically possible when two inductors are mutually aiding and their self-inductance are to be 0? Maybe it is so interesting that the permeability has to become 0. So the fluxes are linking such that the permeability has to become 0. So ideally, theoretical answer is 0, no doubt. So option is A. But practically, it is like a superconductor, then that wire does not have any inductance. Okay. So answer is 0. Now let us go to the next bit. Now the transfer function of the given circuit. Now you know transfer function of RLC. Okay. Now if you go to transfer function, yes, directly if I write, yes, I am writing the same thing. So if I go to the transfer function concept, yes, everybody, convert into Laplace, you know V of S, this is SL, this is R, this is 1 by Cs. Now if you write the transfer function way, yes, we know according to Ohm's law, V equal to IR or IZ, but I is I of S, but what is Z? Z, this all are in series, SL plus R plus 1 by Cs. Okay. But transfer function is ratio of output by input, But output in terms of input is this Vc of S, in terms of input is Is of S, okay, into 1 by Cs. But what is transfer function now? Ratio of output by input. Output is Vc, input is. This ratio Is will cancel. So this by this will come. So this is by default 1 by Cs by, this is SL plus R plus 1 by SC. Now you take LCM SC and take LC common. Yes, you will get this as by default, okay, 1 by LC by, you write in standard form, S square plus R by LS plus 1 by LC. Actually, without this directly formula, you know, na, omega n square by S square plus 2 zeta omega ns plus omega n. Directly that way also you can write, okay, omega n square, you can write that way. And natural frequency of series RLC is 1 by root LC, you know that, okay. And this you know R by L. So this also we teach in transient as a standard transfer function. Okay, from there we teach all these complementary function. If you remember that formula directly, or it takes hardly less than 1 minute to do this way. So answer is yes, option A. Option A. Okay, here option is A. Okay, if you go with, okay. Chalo. Now let us go to the next bit here. What is the value of VAB? Now see, what is the value of VAB is the potential difference between these 2 points. VAB, this is the value. I will write a KVL for that. But to write KVL, first let us find these voltages because these 2 are in series across 10. These 2 are in series across 10. So if I write the voltage, this voltage will be this total voltage 10 into same by sum. Same is 20 by sum is 20 plus 10, that is 30. Okay, 30. Now this voltage also will come here. If you write this voltage also total voltage into same by sum. Same is 40 by sum is 70. Okay, that is also 40 by 7. Now if you write a KVL, simply if you write a KVL, the KVL states it is minus of this voltage, okay, minus of this voltage, that is minus of, okay, 20 by 3, okay, plus VAB is asking this, plus VAB plus this voltage, plus this is how much now directly 40 by 7 equal to 0. So if you solve this, yes, you will get this VAB as, okay, yes, if you solve, yes, if you see after that KVL, VAB will be 20 by 3 minus 40 by 7, which is accurate. You will get this as something like 20 by 21 volt, which is 0.96 volt. 0.96. So 0.96, yes, option is B. Okay, option is B. Okay, 20 by 21, sir, almost 1. Okay, that is the nearest. Okay, then 5 resistance of 10 ohms are connected. Now this is a balance bridge. Okay, what is the resistance? You do node shifting. So if you do node shifting by writing this is A, node A, this is B, okay, and this is C, and this is D. Okay, so A to D 10. Okay, A to D 10. Okay, same, all are 10. Similarly, A to C 10. Okay, A to C is also 10. Okay, then C to D 10. Okay, C to D is 10 ohms. Then again B to D is 10. Okay, B to D is 10 ohms. And finally C to B is also 10. C to B is also 10. But you are looking from AB point of view. Now if you see bridge is balanced and current cannot flow here, so 20 in parallel to 20, again answer is 10 ohms. So in a balanced bridge, if all the arms are equal, okay, answer is also same. So all are 10 ohms, answer is also 10. That is what we teach directly in the class. Okay, now let us go to the, so answer is 10, so option is B. Okay, answer is 10, option is B. Now let us go to the next bit. The Thevenin's equivalent, the Thevenin's equivalent circuit voltage and resistance, both is asking. First of all, if you look from here, what is the resistance? If you see open circuit current, short circuit voltage. If you see, RTH will be directly 16 plus, okay, 16 plus, okay, this in parallel to this, 20 in parallel to 5, because open current, short voltage, 20 in parallel to 5, 20 in parallel to 5, that is 4, so 16 plus 4, 20 ohms. So first of all, RTH is 20 ohms. Now if RTH is 20 ohms, these two cannot be the answer, so answer will be in these two. But to write VTH, what I will do, I will write a KVL here. But to write KVL, let us find this. Now I will do nodal analysis. Like I will take this as reference. Let this be V1, let this be V2. Okay. After writing nodal analysis, yes, if you write the nodal, yes, you know that is V1 minus 24 by 10, V1 minus V2 by 10 minus 3. And here V2 minus V1 by 10, V2 by 5, and this is plus 3 if you write. And after solving, you will get this V2 as, yes, after solving, you will get this V2 as minus 6 by 5 volt. Now simple. Now the moment you get V2 as minus 6 by, that is this minus plus 6 by 5, 6 by 5. But what about this voltage? See, this already 3 amperes is going. Here it is open now. 3 amperes is going this way. 3 into 16. This is plus minus 48 volt. 48. 16 3 1. Then I will write a KVL because this itself is my Thevenin's voltage VTH. If you write a KVL, yes, that KVL if you write, yes, plus 6 by 5 minus, okay, plus 48 KVL clockwise plus VTH is 0. Now if you solve, this VTH will be, okay, minus 6 by 5 minus 48, it is minus 49.2 volt, simple, minus 49.2 because VTH. See, I wrote a KVL. First I did nodal equation to find this voltage, then this current is already going here, 16 3s are 48, so I wrote a KVL to get VTH. So VTH is minus, so VTH is minus 49.2 and RTH is 20, so option is C. Okay, yes, option is C. Now let us go to the next bit, everybody. Let us go to the next bit. What is the maximum power? Now he just did not ask what is the value of R. What is the maximum power transfer to R? If you talk about what is the maximum power transfer to R, first of all, let us find R. Now if you find R, short voltage, if you look from R point of view, R is RTH. If you look that way, R is RTH. Short this, if you look from there, that is 10 in parallel to 20 plus this is 25 in parallel, 25 in parallel to 5. Okay. So if you look from here, open this, short this. That short I can write here. And looking between these two, 20 in parallel to 10 and 25 in parallel to 5. That will be RTH. Now that RTH itself is RL. Okay. And you will get this something around 325. Okay. 325 by 30. Then what about VTH? Again, open circuit voltage. VTH will be this open circuit voltage. Again, to find this open circuit voltage like we did in one previous problem, I will find this voltage and write a KVL. But again, what is this voltage? Voltage division rule. This voltage will be total voltage 60 into same by sum. Same is 20 by sum 30. But what about this voltage? This voltage also will be total voltage 60 into same by sum. Same is 5. Sum is 30 again. Okay. Now you write a KVL. If you write a KVL, yes, that KVL if you write, you will get this something as VTH as 30 volts. VTH as 30. Now clearly Pmax value is asked. Pmax is VTH square by 4 RTH. VTH square is 30 square by 4 into RTH is 325 by 30. Okay. Yes, you will get this as 20.77 volt. 20 point. So VTH is 20.7. Watts, 20.77 watt because he's asking power na 20.77. 20.77 is option D. Okay, 20.77 is option D. Okay, yes, option D, 20.77 watts. Now let us go very interesting problem. Now this is a direct observation problem. Now see, he is asking the component's state during transient state, at the instant when change is occurring. Now see, now first of all, yes, first see the state, which is the correct statement is asking, but let us go to the first statement. If there is no current flowing through inductor at t equal to 0 minus, then inductor will act as open circuit at t equal to 0, because inductor will not allow sudden change in current. If there was no current initially, then also there should be no current, it should act like open circuit. That means inductor without any initial condition is an open circuit, That is true. So first equation is correct. First statement is correct. Second, if there is no voltage across capacitor, yes, if there is no voltage across capacitor, that means capacitor also does not have initial condition, and t equal to 0, it acts like short circuit. At t equal to 0 plus, it acts like short circuit. It acts like short circuit. But you see, he is asking capacitor acts as open circuit. So second statement is wrong, second statement. But what about third statement? If the current value I of 0 flows through the inductor at t equal to 0, then inductor can be regarded as a current source, because this is third statement where inductor with initial condition. Now we know this. First of all, inductor acts like open circuit, okay, but initial condition is also there. Here initial condition is not there. Initial condition, that inductor also will not allow sudden change in current. So I have to represent like this. So finally it acts like a current source of I0. So see the statement. If the current value of I0 flows through inductor at t equal to 0 minus, then the inductor can be regarded as a current source of I0 at t equal to 0. This is also correct statement. So out of 3 statements, statement 1 and statement 3 are correct, but 2 is wrong. So 1 and 3 are correct. So 1 and 3 are correct is option C. 1 and 3 are correct is option C. Okay, that is a very, very good problem. Now see, what is the value of V0? Now it is an AC steady state problem with RMS value of 4 angle 90, and these are impedances. Now directly nodal analysis, I will write nodal equation KCL. So if you write nodal equation, V0 by J6, okay, this is minus of 4 at an angle 90, okay, and this is V0 by minus J3 is 0. So if I write V0 as here 1 by J6, okay, or directly let us write 1, okay, 1 by J6, this is 1 by minus J3 equal to 4 at an angle 90. But what is this? V0 is, and this is minus J by 6 plus J by 3 equal to 4 at an angle 90. But why I wrote this way? Because J means 1 angle 90. 1 angle 90 you take up 1 angle minus 90 minus J. This is 1 angle minus 90, you take 1 angle plus 90, J. Now if you take this here, LCM here, this 6 clearly, okay, this is simply minus 2J plus J, okay, this is plus 2J, J only, J equal to 4 at an angle 90. Yes or no? Because this is plus 2J minus J. So simply, but J is 1 angle 90, J is 1 angle 90, 90, 90 if you go here, so V0 is simply 24 volts angle 0, 24 volts angle 0. Because you see, this J you bring here, angle 90, 90 minus 90 is 0, 6 4s are 24 volts. So final answer is 24 angle 0, 24 angle 0. That is why he did not mention any angle there, okay? Yes. Now let us go to this. The value of power consumed by a balanced star connected in terms of balanced delta. Actually the direct bit. Delta load will absorb 3 times power than star load. Here the value of power consumed by balanced star connected load in terms of balanced delta. So balanced star will be balanced delta by 2. Balanced star will be balanced delta by 3. So yes, option is C. But how to prove it? See, in exam, if you don't have such an idea, just take 3 resistors. Suppose 3 resistors are in star. Balanced means I will take equal 1 ohm, 1 ohm, 1 ohm. Let us say line voltage is 10 volt. Now here what is the power consumed? Power consumed in star will be 3 V phase, I phase, 3 V phase. Okay, V phase is line by root 3, I phase, phase voltage by resistance, that is 10 by root 3 by 1, and power factor of resistor is already 1. So if you see this, root 3 will cancel 100 watt. But what about balanced star? If you take simple balanced delta, yes, if you take balanced delta, again here 1 ohm, 1 ohm, 1 ohm, again line voltage is 10 volts. But in this case, if you calculate power, this will take 10 V square by R, 10 square by 1. This will take 10 square by 1, 10 square by 1. So this is 3 into 10 square by 1. So that is 300 watts. 300 watts, that is P of delta. So for the same balanced system, a delta load will absorb 3 times power than star load. So, or I can say the vice versa, the star load will be P delta by 3. Star load will be P delta by 3. So option is clearly, yes, C. Okay, let me check it. Yes, option is clearly C. Yes, let us go to the next bit. Now see, the Z parameters of 2-port network, here Z parameters are given. Okay, Z11 that is 20, Z22 30, and Z12, Z21 is 10. Okay, now he is asking ABCD parameters. Now if you observe, see this ABCD parameters, A is Z11 by Z21, that is clearly 20 by 10 2. Okay, B is delta Z by Z21. But what is delta Z? Determinant. AD minus BC, that is 500 by 10, that is 50. Then C is clearly 1 by Z21. 1 by Z21 is 1 by 10, that is 0.1. And finally D is Z22 by Z21. This is the direct formula we give in the class in your notes. But you have to remember Z22, that is 30 by 10, that is again 3. So answer is, this is 250.13. 250, okay, 0.13. So option is D. 250.13. Go in that way, option is D, clearly D. Now, yes, now another question where there are 3 coils are mutually coupled, where the self-inductance of each coil is 10 Henry, 5 Henry and 6 Henry. But these 2 are mutually coupled where dots are in the entering side 2 Henry. These 2 are mutually coupled where in the first case dot is entering side for current and here dot is leaving side. That means these 2 are mutually opposing. And 1 and 3 also coupled where this is in the entering side, this is in the leaving side. When such question with more than 2 coils come, don't do any formula, don't apply. This is unnecessary confusion. Write self-inductance including mutual inductance of each coil separately. Let us say this is LA, LB, LC. Now LA. What is LA? Self-inductance is 10, but there are 2 mutual inductance between 1 and 2. Entering, because dots in the entering side, between 1 and 2. Entering plus 2, between 1 and 3. Entering, leaving, see 1 and 3, entering, leaving, this is minus 1. So this total becomes how much? 11 Henry. What about coil 2? In coil 2 also 1 self and 2 mutuals are there. Self is how much? 5. 2 mutuals. Between these 2, entering, plus 2. Between these 2, entering, leaving, minus 1. So this is 7 minus 1, 6. But what about coil 3? Self is 6. Again between 1 and 3, entering, leaving, minus 1. But between 2 and 3, entering, leaving, this is also minus 1. So 6 minus 2, 4. Now if you add all these 3, see, 11 plus 6, 17, 17 plus 4, 21 Henry is the final value. 21 Henry is option B. Standard bit we do in our class. There are so many models, but more than 2 coils, I better suggest don't use any formula. Now, an initially uncharged means initial condition is, that means V of 0 is 0 volts. An initially uncharged 1 milli, C is how much? 1 millifarad. This is very important. 1 millifarad capacitor. Okay, what is the voltage at 2? Now this is given this current. Okay, he said this is a 1 millifarad capacitor with no initial condition, has the current shown in the figure. What is the voltage at 2 milli? That means this ramp current is given. What is the voltage? But what is the Ohm's law for capacitor? V of t is equal to V of 0 plus 1 by C integral current function dt. And is asking the value, is not asking us to plot. Plotting will be integration of ramp will be parabolic. But here we want the value. So that is the definite integral we have to do. So initial condition is 0. C is how much? 1 by 1 milli. Integral from where to where is asking? Yes, up to 2 milli. So 0 to 2 milli current function. But what is current function? Ramp. Opposite by adjacent. Slope is opposite. 100 by 2. That is 50 t dt. That's it. So this is nothing but 50 by 1 milli. Okay, and this become t square by 2. T square by 2. But limits are what for t square? For this t square, the limits are 0 to 2 milli. Now you bring to this side, that is 25 by 1 milli. Okay, 25 by 1 milli. And this is 2t square, that is 4 milli square minus 0. Milli will cancel, that is 100 milliampere. 100 millivolt. Okay, let me correct it. 100 millivolt, because we are writing V is 1 by C, 100 millivolt. So 100 millivolt is option B. Okay, yes, 100 millivolt is option B. Okay, so with this I confirm all network bits are done and relatively very easy. Overall, I could say compared to last year, network bits are very easy and very straightforward. Okay.
welcome back. So here is the one question related to the electromagnetic fields. So here is a question, what is the value of the magnetic field on the axis of that is perpendicular to the plane containing circular loop of shown? Yes. So this is A, this is R. So it's asking what is the magnetic field away from the center of the circular loop which is carrying the current I amperes. So what is the formula? We'll go for the formula. The formula here is B is equal to, I'll write only the magnitude. I'll write only the magnitude because in the questions is asking only the magnitude. So the B is equal to mu into I into A square divided by 2 into A square plus B square to the power of 3 by 2. Done? So this is the formula. Let us make some adjustment according to the options here. C here, we'll consider it as a mu naught, nothing is mentioned. Fine. C, actually that B is this distance away from the center. Fine. So you can notice from here, what is this A square plus B square from the diagram? A square plus B square is equal to capital R square. Substitute there. So B is equal to mu naught into I into A square divided by 2 into, in the place of A square plus B square, you can substitute R square to the power of 3 by 2. And I'll multiply divide by the pi on both sides. Fine. So it is mu naught into I into A square into pi divided by 2 into R cube into pi. This pi R square is the area. Area into current which is flowing in the circular loop is nothing but a magnetic moment, fine, which is represented with the M. So you must have maintained some clarity in the question. So he has gone with some standard notations. Anyhow, so what is the answer here? M here indicates the magnetic moment, we'll say. So you can check out mu naught into M divided by 2 pi R cube. Option A is the answer. Okay, this is all for now, and the session will be continued by the other subject matter expert. Fine. Thank you. Good luck.
So I'm here going to discuss about electrical materials. Now here is a question. The question is related to the permanent magnet properties, right? So the permanent magnet have low permeability and high cohesivity and high Curie temperature. So A is the correct answer for this question. So properties of permanent magnet they asked, right? Next question, the opto-isolator. See, the opto-isolator works only with the DC coupling. See, out of all these 4 options, only the first option that will give you the correct results. So A is the correct answer for this question because it allows only DC coupling. Next, which one of the following is the correct related to type 1 superconductor? See, type 1 superconductor, different examples and their Curie temperature is given. So mercury is 4.12 Kelvin temperature. So mercury is 4.12 Kelvin temperature, and lead is 7.196 Kelvin temperature. Aluminum is very low Curie temperature, that is 1.175. So B is the correct answer for this question. Straightforward question it is. Next, organic semi-superconductors are composed of. See, organic superconductors are composed of electron donor is an organic molecule and electron acceptor is a non-organic molecule. Remember, electron donor is an organic molecule and electron acceptor is a non-organic molecule. So A is the correct answer for this question. Right. What is the property of isotropic material that must be satisfied? See, isotropic materials have same material properties in all directions. So it has same electrical properties for the various directions of appliance of electric field in all the directions. Okay. It has a different electrical properties wrong, different electrical properties wrong, same electrical properties in opposite direction, that is wrong. So A is the correct answer for this question. It's a very simple question. Right. What is the order of resistivity of conducting materials? The order of resistivity of conducting material is 10 power minus 6 ohm meter to 10 power minus 10 approximately ohm meter. So appropriate answer for this question is A. The most appropriate answer for this question is A, because this won't be there, this won't be there, this won't be there. 10 power 12, 8, all these are not correct. So this is the most appropriate answer. Right. What are the properties of good insulating materials? Good insulating materials have high dielectric strength. It should have high dielectric strength and volume of resistivity of high value and low dissipation factor. So this is the one, because remaining options low dielectric strength is given, it should be high dielectric strength. This is the correct answer. It's a very simple question. Now, what is the value of Curie temperature of iron? Curie temperature of iron is 768 degrees Celsius or 1041 Kelvin. So Kelvin, in terms of Kelvin, if we take, this is the answer. So A is the correct answer for this question, 1043 Kelvin. Right. Which one of the following is the correct relationship among the Curie temperature? See, remember the Curie temperature, if you talk, the cobalt has more Curie temperature than iron, than nickel. Nickel is the least Curie temperature. So if you see the options here, nickel Curie temperature less than, iron Curie temperature less than cobalt. So A is the correct answer for this question. A is the correct answer for this question. These are the questions related to the material science. They are very easy questions.
Hi. Engineering mathematics. So look at this question. Consider a random variable with uniform PDF. Assume the random variable. Then we were asked to find E of y. E of y means E of x square. Do you know if x is uniformly distributed in the interval a comma b, E of x square is a square. A square means minus 1 by 2 whole square plus b square plus ab by 3. So this cancel 1 by 4 divided by 3, that is 1 by 12. Do we have an option of 1 by 12? Yes, 1 by 12. Therefore option B is the right answer. This is basic level simple question only. You people can solve. I need not say the answer. We were just asked to find average weekly earning. That means mean value. Next, let x be a Poisson random variable such that P of x equal to 2. P of x equal to 2 means lambda power 2 e power minus lambda by 2 factorial equal to 9 into P of x equal to 4. Lambda power 4 e power minus lambda by 4 factorial plus 90 into lambda power 6 into e power minus lambda by 6 factorial. So e power minus lambda, after simplifying this, we get lambda equal to 1. We only have to simplify this. After simplification, it just leads to option A, that is 1. And you observe this, a random variable x takes the values with the takes values 0, 1, 2, 3, 4, 5 up to infinity. probability of x is proportional to, observe this, probability of x is proportional to x plus 1 into 1 by 5 whole to the power of x. So from this p of x equal to k into x plus 1 into 1 by 5 whole power x. So you have to write the table like this. These are x values 0, 1, 2, 3, 4, 5 up to infinity. If you take x equal to 0, this is k, x equal to 1, then it is 2k by 5, x equal to 2, this is 3k by 25 and so on. So to get the k value, sum of the probability is equal to 1. So sum of the probability is equal to 1, you will get k value. After that, what we were asked to find, probability of x less than or equal to 2. Probability of x less than or equal to 2 means probability of 2 plus probability of 1 plus probability of 0. This plus this plus this, sum of the probability is equal to 1, you will get k value, and sum of these three values you simplify. After simplification, it leads to option C, that is 608 by 625. But one thing, sum of the probability is equal to 1. During the process of simplification of sum of all these infinite number of terms, somewhere in the middle, it will reduce to this form. So you have to apply 1 minus x whole power minus 2, that is 1 plus 2x plus 3x square plus 4x cube. I mean AGP, arithmetic geometric progression. With the help of that, sum of the probability is equal to 1, then you will find k value. Next, you observe this, a die is thrown as long as necessary for 6 to turn up. Given that 6 doesn't turn up in the first throw, what is the probability that more than 4 throws are necessary? More than 4 throws are necessary for occurrence of 6 means, as we already know that first throw 6 doesn't occur and the next 3 throws also 6 doesn't occur. So 6 does not occur in the next 3 throws, that is 5 by 6 whole cube, that is 125 by 216. Therefore option A is the right answer. Next, this is very basic level question. So A and B are independent events. If A and B are independent events, probability of B given A will become probability of B. So probability of B 1 by 2, probability of A 1 by 2. If A and B are independent events, P of A and B formula, P of A, that is 1 by 2, plus P of B, that is 1 by 2, minus P of A intersection B. A and B are independent events means P of A intersection B will be P of A into P of B. That is 1 by 2 into 1 by 2, 1 by 4. This is 1 minus 1 by 4, that is 3 by 4. Therefore, option D is the right answer then. Now, this is combined standard deviation. You can solve, otherwise, next few more questions my colleague will continue.
Okay, coming to the next problem, this is a question in differential equation. Solution of the initial value problem with two conditions given, y of 0 is equal to 6 and y dash of 0 is equal to 2. No need to solve this problem, simply you verify the options. Say, suppose in option C, suppose if I substitute y of 0 is equal to 6, means if I substitute x is equal to 0, y should be 6. Yes, substitute x is equal to 0 here, 4 plus 2 you are getting 6 or not. So, in remaining options you will not get that number 6. So option C is right. No need to solve this problem. Clear? Now coming to the next problem, problem number, okay, this is d power 4x by dt power 4 plus 4x is equal to 0. So
what is auxiliary equation? What is auxiliary equation? AE is d power 4 plus 4 is equal to 0. D power 4 plus 4 is equal to 0 means you can write it as d square plus 2 whole square minus 4d square. If you simplify, you will get like this only, you see. D square plus 2 whole square in the sense d power 4 plus 4d square plus 4. So that for the compensation I have taken minus 4d square. This is nothing but again this is in a form d square plus 2 whole square minus 2d whole square is equal to 0. That is nothing but now it is in a form a square minus b square. What it is, a plus b into a minus b or not? Plus b means plus 2d into a minus b means d square plus 2 minus 2d is equal to 0. Now here we will get one quadratic equation, here we will get one quadratic equation. Means if you solve these two quadratic equations, what is the value of d means 1 plus or minus d, 1 plus or minus I, and second one is nothing but minus 1 plus or minus I. So roots are nothing but complex roots. All four roots are complex roots. If you know already, if complex roots occur, so what is the general solution? Say here option C satisfies using that. Is it? Now coming to the next problem, what is the particular integral? Only particular integral they asked here. Pi is, how to find particular integral? Pi is, yp is nothing but 1 by f of d. What is f of d here? D cube plus 1 into cos of 2x minus 1. So here cos Ax, this is the type 2, okay, non-homogeneous differential equation type 2 model. Here A is equal to, in place of d square you have to substitute minus a square, already you know, d square into d plus 1 you can write into, that is cos 2x minus 1. In place of d square I have to substitute minus a square. So what it is, 1 by, in place of d square minus a square means minus 4d plus 1 into cos 2x minus 1. After that you have to rationalize the denominator, okay, and then you can find yp finally. So here just next step you rationalize it and then you find yp. Option will coincide as option C will coincide for this solution. Okay, now coming to the next problem is, this is a partial means total derivative related problem. U is equal to x into log xy and x cube plus y cube plus 3xy is equal to 1. X and y are connected by a relation, x cube plus y cube plus 3xy is equal to 1. What is the question here? Total derivative definition you follow, du by dx. What is required to me? Du by dx is nothing but dou u by dou x into dx by dx, is it? Plus dou u by dou y into dy by dx. Okay, what is dou u by dou x? That is dou u by dou x into dx by dx means u with respect to x means that is x into log of xy again into y plus log xy. Okay, UV rule you can apply. Into dx by dx is 1 plus dou u by dou y. U with respect to y means that is x log x is nothing but here x into 1 by xy. First function into derivative of second function, that is nothing but 1 by xy with respect to x, y plus log xy into 1. Next, and with respect to y means that is here also what it is, log x derivative is 1 by x or not? That is 1 by xy with respect to y. With respect to y means that is nothing but x. Okay, into dy by dx. Okay, what is, how to find dy by dx? Actually, suppose any function in implicit form given to you, why there is one, this is in a form, actually this is in a form f of xy. Okay, what is dy by dx? Dy by dx, how to find dy by dx in implicit form of f of x? That is nothing but minus of dou f by dou x by dou f by dou y. Just Find dy by dx first. You find dy by dx from this. So minus of dou f by dou x by dou f by dou y means what it is? With respect to x means minus of f with respect to x. 3x square plus 3y. What is the denominator? Dou f by dou y means 3y square with respect to y plus 3x. You say this. In place of dx by dy, the dx by dx, that is 1. In place of dy by dx, I have to substitute this, that is minus 3 minus of minus 3x square. We will get like this finally. Minus 3x square minus 3y by 3y square plus 3x you can. That's it. And you simplify, okay, after simplification, finally we'll get like this, option D will coincide, you check it. Okay, after simplification, option D will coincide. Yes. Now coming to the next question, this is a complex integration related question. What is the value of integral 0 to 2 plus I mod z whole square? What it is? Z bar is nothing but z is equal to x plus iy. So what is z bar whole square? What is the question here? Integral 0 to 2 plus I means that is nothing but 0 0 to x2 y1. 2 comma 1. Z bar is nothing but what it is? X minus iy whole square. Dz is nothing but dx plus I dy. Dz is nothing but dx plus I dy. So along the line y is equal to x by 2 means along the line y is equal to x by 2. So where y is there, you can substitute x by 2. So what is dy? Dy is equal to dx by 2. Okay. So complete x variable you convert as complete y you convert as x variable, in sense no need to take y limits, you just take x limits only. X varies from where to where? 0 to 2. Next step you can write it as x varies from 0 to 2, x minus what is y? Y is nothing but x by 2 or not? Ix by 2 whole square dx plus I dy is nothing but what it is? I dx by 2. So completely it is nothing but integration with respect to the variable x. This integration is very easy, you know how to integrate. The final answer after calculation, final answer you can observe it as option A is correct. Okay. So these are the problems given in mathematics. I hope you all did well. All the best.
Hello my dear, now we are going to discuss the questions related to the power electronics. So total 13 questions they asked on power electronics. A power diode can be used as a switch because its resistance can be controlled with. We know power diode is an uncontrolled device. So whether it will be in an on state or off state, it totally depends on its biasing. That is nothing but applied voltage. Okay. So power diode resistance, when it is in an on state, the resistance value is very less. When it is in an off state, resistance value is high, right? So its resistance is controlled by using the applied voltage. So option D is the correct option, right? The reverse current reduces and the voltage across the power diode grows more negative during the turn off process of a power diode. This time is called. So this question is related to the dynamic characteristic of power diode during turn off, right? So if you check during turn off, your current flowing through the diode goes into the negative now, and that time is known as a reverse recovery time. Option C is the correct option, right? What are the significant advantages of MOS power transistor, that is MOSFET, over the bipolar power transistor, that is power BJT, in the pulse power supplies? Okay. Yeah, if you check in case of MOSFET, we know the input impedance is high, na, right? So high input impedance. High input impedance. You can say input impedance or input resistance also. And if input resistance or input impedance is high, then what is the input current? My input current is very small, right? It is small in the range of nanoampere. If you check the options here, they have given, yes, high input resistance, and here also high input resistance. But if you check the current range here, the input current here, it is nanoampere, that is very small. And as the input impedance is high, definitely input current will be very small. And here input current is kiloampere they have given, which is not true, na, right? So correct answer is option A. Option A. In a gate turn off thyristor, the turning off is achieved by, we know GTO is a fully controlled device. It can be turned off by circulating the negative gate current. So option D is the correct option. Next, the function of a capacitive filter in a diode bridge rectifier is 2. So here they are talking about the capacitive filter. The capacitive filters are generally used in a rectifier in order to reduce the ripple in output voltages. Here if you check the options, first is remove small load current ripples from the rectified output signal. So here they are talking about the current ripples, which is not true, which is not true. This is specifically used for ripple voltage, right, to reduce the ripple voltage. Next, minimize the voltage variations in AC input signal, not at all, no relation at the input side. Reduce harmonics in the rectified output signal, yeah, we can say it is helpful in reducing the harmonics also. And next, introduce more ripples into the rectified output. So the most appropriate answer is option C, right, option C. The use of an inductive filter in a rectifier circuit provides satisfactory performance only when. So here inductive filter is used, right, to reduce the ripple in a load current, right. If your load current is having comparatively small value, then to reduce that ripple, okay, we are using the inductive filter. So option C is the correct option. High load current means it is like a highly inductive case, okay. So that is not having, if load inductor is having high, then no need to go for the inductive filter even, okay. So option C is the correct option. In a separately excited DC motor is to be controlled in a first quadrant only. The converter is used is. So for first quadrant operation, we know which converter is there, single phase half controlled rectifier. This will give you only first quadrant operation. What about the single phase full converter? It gives first and fourth quadrant. What about the single phase dual controlled rectifier, means dual converter? Dual converter gives a 4 quadrant operation, and even 4 quadrant chopper, that also gives 4 quadrant operation, okay. So first quadrant means only single phase half controlled rectifier. Option A is the correct option. The static carry bus drive can able to provide, we know this is a one of the famous drive method. It is used for variable speed, that is speed control. It gives the speeds below the synchronous speed. Which one of the following statement is correct regarding the series resonant inverter? Okay, the load current is a square waveform, which is not true absolutely. The output voltage waveform depends on the damping factor of the load impedance. If you check the series resonant inverter, here output current depends on this damping factor, but here they have given the output voltage, so this is not true. The trigger frequency is higher than the damped resonant frequency. Yes, my trigger frequency is comparatively very high, right, and damped resonant frequency is a less, okay. So in power electronics, my triggering frequency is a very high. So that's why option C is the correct option. And fourth the input voltage waveform depends on the damping factor. No, input side waveform is not having any relation with your load damping ratio. All right. So therefore option C is the correct option. Next, if a single phase full bridge voltage source inverter operates with a resistive load, they are talking about the voltage source inverter and load is resistive. The nature of the output current is, we know in voltage source inverter, output voltage is a square function for all the loads. And if the load is resistive, then my output current is also having the same nature as that of the load now, means it is a square function. So here it is a square waveform. It is a square waveform. And which one of the following cores is used for large mains transformer, that is like your pulse transformer, to reduce the AD current loss of high frequency operation in power electronic circuit? So here generally which core material is used? Ferrite core. Okay, but here specifically they are talking about the to reduce AD current loss. So specifically to reduce the AD current loss, we are using the compressed ferromagnetic alloy core. Okay, right, compressed ferromagnetic alloy core, compressed. Next, when an induction motor and a heater are supplied from a phase controlled single phase AC voltage controllers, then here we are having the induction motor as a load and the heater as a load, right? So heater is nothing but simply your resistive element. Okay, it is like a resistive load, and induction motor is the machine that converts your electrical to the mechanical. So here if you check the options, they are talking about fundamental component and the harmonic component. In case of induction motor, if harmonic components are present, then that will degrade the performance of the motor, right? So here therefore in case of induction motor, only fundamental component of output voltage and current is useful in the induction motor. But whereas in case of heater, definitely fundamental should be there, but in addition whatever the harmonic components are also there, those also will help in producing the heat, right? So that's why my correct answer is option A. But fundamental and harmonics are useful in the heater, right? So correct answer is option A, right? So these are the questions from power electronics, and my dear friends, these are the questions they asked on in ESE 2024 prelim examination. Okay, hope you answered well, and by tomorrow or day after tomorrow, the final solution, that is answer keys, will be uploaded on ESE Engineering Academy website. Okay, you can refer it. Yeah, thank you and all the best.